And
These lights. Oh, they're already on. Steve, can I turn these lights off?
yeah, I would leave it the way it was.
Oh,
Yeah,
all right.
Okay, you can try it with the side light.
No, I don't know how to turn them off. Okay, welcome to our weather watch for today, both in-house and remote guests. We are talking about our weekly weather discussion involves a look at the current weather, a look at what might have been happening of interest over the previous week, and then a look forward into the future, and sometimes that varies in time. Sometimes if something's really bearing down on us, unlike today, we might look 2 days in advance and call it a day. Other times we'll look 5 to 10 days in advance, and even sometimes under Michael Morgan's influence, we'll look several months in advance. Thinking about the snowstorms that he loves so much, or snow events.
Right, events.
Yeah. So let's begin, as we often do, with our visible satellite image over the continental United States and adjacent waters. And not for the yeah, we want that big one. Yeah, that's great. Okay. So a little bit of it is just before the sun comes up across the central United States, but you can see the main feature of interest across the continental U.S. and adjacent waters today is this cloud band that goes across from maritime Canada all the way down into the desert Southwest, appears to emanate from a disturbance off of the coast of Mexico in the subtropics. And then also there's perhaps some connection to the circulation around this feature off the west coast of the United States. We'll pay attention to that as well. We'll see later on the radar that it's precipitating fairly heavily across parts of Kentucky and West Virginia, and even now into western Pennsylvania. And as far as I know, whether or not the lightning detection network is down or the mosaic feature is down today, I don't know. I didn't have time to check observations at the surface. We'll do that together, I guess. But it did not appear to be convective, at least in terms of spawning lightning strikes. And so that's interesting, and points toward something that might have a very strong dynamical component to the forcing for the vertical motion that's resulting in the heavy precipitation. There's also an orographic component as something of this structure bears down on the western side of the Appalachians, with probably a little bit of enhanced descent as the whole structure moves that way. But I don't think that's the main thing, and we won't, unfortunately, have a slew of diagnostics to look at that. We'll look at a couple and we'll criticize them for where they were placed in the vertical by well-meaning but otherwise not particularly well-informed scientists, namely myself. Okay,
Couple.
oh yeah, well, we're right. Somebody else.
Point out a couple things. It's kind of interesting. You can sort of see our past week's sort of historical snowfall, or the last vestiges of it over the upper Midwest, which shows up really nicely in the visible imagery. And also, maybe we can zoom in on this, Pete. The southeast United States, particularly the southern Louisiana and the southern states bordering the Gulf of Mexico. Which was one of the first times I can recall we ever looked at these images too much. It's not showing up as well as I thought, particularly over southern Alabama, and actually it does show up now. That cumulus that's occurring from southern Louisiana all the way through Alabama, Mississippi,
Oh yeah, there you go.
Georgia. It's just an indication of I guess, a moistening boundary layer, and the propensity for, I guess, these cumuliform clouds to begin forming. And it's a sign of the spring. The earliest signs of spring beginning to return.
It's hard to tell which one's above which. This, in terms of the low clouds, I can't tell. It looks like they're cirrus clouds, so they're probably higher, but it's hard to know for sure if that's the case. These things are just kind of sliding perpendicular to the motion almost of the cumuliform clouds. So very interesting, right? Yeah. And then, look at that. Look at the detail you get of the delta region. It goes 16. It's unbelievable. This major part of our southern civilization is built on silt from Mississippi River. And everyone knows that, but you don't often see it so obviously as you do right there.
It's strikingly clear on that. And then the final thing I wanted to comment, we went back to the prior image, sorry, Pete, that will play a role in the forecast for the central part of the United States coming up, is you go all the way from the Eastern Caribbean and just sort of follow the cloud motions from there all the way into the Gulf of Mexico. There's this broad, that's on the southern edge of a broad subtropical ridge that's beginning to get established. And that's going to, when you get these sorts of setups with some sort of baroclinic zone like we have today over the, I guess, the mid-Atlantic, you get these big rain events. We're going to see another similar rain event setting up. And I think this is the second or third of these that we've already seen already in the last couple of weeks. Just this persistent southwesterly flow off from the Caribbean and the Gulf of Mexico is going to set the stage for lots of precipitation over the central U.S. We'll see that.
And something that's always interested me too is the nature of the subtropical anticyclone, maybe particularly at the end of the winter, because some component of it, I suppose, has a relation to the heavenly circulation, right? But then a component of it also has a relationship, I would imagine, to the southeastward progression of Arctic anticyclones, because they move in the direction of the thermal wind, and that's exactly where they're headed. So and they amalgamate. I wonder if there's a way that a person can actually separate the contribution from the mid-latitude set of disturbances and the tropical circulation cell. Because if this thing gets established relatively early and in a relatively strong fashion, then I think the features that you're talking about are the portents for heavy rain in the lower Mississippi River Valley have come a little bit earlier. And it's coincident also with the tornado season maximum, which is right about now, beginning right about now in that part of the country. So there's a whole bunch of interesting things going on there that are worthy of consideration, but it take a little bit of research time. But as Michael pointed out, and unless you're on the ground here in Madison, you might not have noticed, we had a widespread snow cover, probably on the order of 8 or so inches over the last fall, from early last week to the end of last week. In just a couple of days with high sun angle, clear skies, and temperature around 40 degrees, induced a lot of melting. Every south-facing hill or even hillock is now pretty much without snow on it. So it just disappeared in rapid fashion. And it was melting even overnight, as you saw locally. Using all those little slippery spots, because the ground is actually -1 C, but the air right above it is +3 C. So you have trouble with footing if you're not careful. And you can't see it on the visible, but we might even see a hint of it in the infrared. But this is a spot in northern Hudson Bay where we have some of the coldest temperatures at 850 that we've seen all winter long. I think they're below -40 at 850, and that's been the case most of this week. It's really been quite remarkable. Earlier this week, there was a beautiful cyclone just in the wrong spot between the southern tip of Greenland and Iceland. And it was deeply wrapped up, probably in the low 950s, I think it was. And you could see around the periphery of the main circulation center a bunch of little swirlies developing, all of the same scale, and not living very long, but one after another developing absolutely beautifully infrared. So some really monster type disturbances, probably qualifying as storms. Up in the Atlantic.
Call them that.
Yeah, even the most odd skeptic might
marginal.
call them a storm in that case. Let's take a look at the West Coast satellite image. And I'll comment here, as I've said a number of times, we have a few visitors, but maybe the infrared is probably better. The western, the Pacific Basin circulation has just seemed off to me all winter long. There haven't been a series of beautiful roll-up storms into the Pacific Northwest as we
Rats are failing.
Rats, too bad. Well, it's actually not so bad because there's just nothing to show per se.
We do have that, I mean, this is not
I don't know that.
it's not a satellite
Well,
loop.
of course you don't think so.
We don't have a satellite loop, but the loop that Pete created, maybe we can look at that next week.
Oh, okay.
To talk about what happened over the winter is that long-lived mean sea level pressure
Oh, right,
loop.
right, right.
Actually,
This goes back to like November, so it's going to be going.
through now, I don't know if you want to go
Yeah,
look that loop
probably
out,
not.
but we could look at it and have something to say next week.
Yeah, just doing it on the fly. There's no way to leave it. Let's take a look at the radar depiction across the United States. So here's the composite across the U.S. from the last 6 or so hours. I guess it's ending about 12:10 p.m. Central Time. And so here's this precipitation band, quite intense along the Ohio River Valley, and now moving into the higher hills of the western Appalachians. And as I said, at least in the lightning detection network, no particular flash activity associated with this, even though precipitation is in the 45 to almost 55 dBz level. So heavy precipitation in southern Ohio and parts of southern Indiana. So creek and stream flooding almost surely occurring there, as you probably have exacerbated snowmelt from prior events earlier this winter, although it hasn't been a particularly snowy winter in this part of the country. It was early in December, I think, they had an event, but not since. And then this is holding together reasonably well, although starting to lose a little bit of shape, and that's probably a function of the orography at the highest peaks of the Appalachians may reemerge as a fairly continuous looking feature that comes out of the high hills. And it's all tied to a fairly intense cyclone over the Labrador Sea, just to the east of the Canadian Maritimes, that I think is down into the 960s or something like that. And it's got a really impressive cold frontal structure that we'll see from the observations in the middle and upper troposphere in just a minute. So that's kind of an interesting feature. And on the Pacific coast, the only place where it's precipitating is in the higher terrain in the Puget Sound and northwestern Oregon. Maybe some of the lower lying areas near Olympia are seeing some precipitation as well. We'll see on the surface map exactly perhaps where it's precipitating in that part of the country, but that's about it. And we have a beautiful sunny day here today, although as we'll see later, we have a the classic battle going on in the late winter between insulation, which is getting stronger and stronger, and cold advection, which is episodic. And today we have a case where the two features, temperature advection and insulation, are working in contrast to each other, in opposition. Wednesday they worked in concert, and the temperature soared into the low 40s, even under some thin clouds. Okay, let's take a look at the super peaks, and I guess we'll start at 500 millibars peak. Oh no, surface map. Sorry, look at the surface map first. Yeah, and let's see if we can't see. I don't think there's going to be any thunder or observations in any of these obs on the map. So light rain through Pennsylvania all the way as far east as Philly, 56 over 45. That's pretty nice. 53 in Boston, beautiful day. 77 along the inner shore of the Outer Banks. 65 at Cape Hatteras. 78, 76 in Rollin. Beautiful day down there. What's it like in West Lafayette? It's about 37 and 5 points shy. So that's pretty nice. Great night last night at the Kohl Center. That was exciting. 23 over 3 for us, bone dry. It gets colder and dry as we move to the north. Temperatures in the teens. With slight northwesterly winds over the western part of our state, and then suddenly they go back to southwesterly over Minnesota. That's curious. And northwesterly over much of Iowa and Illinois. So I think this is a function of the anticyclone that's unanalyzed here. You can see it kind of centered right about here, and it's kind of the air is coming around like this. So the highest pressure is maybe somewhere here in central Iowa, 1032.6 through 1032.7.
There's a 32.9 in northwest. Yeah.
Sorry?
South of
Oh, yeah, 32.9 down here. Yeah, okay, so about 1030 and there's a 1033.4. Yeah. So it's centered over eastern Kansas, so sort of just to the west of Kansas City, so the circulation clearly anticyclonic around it.
Look at down south of Lake Pontchartrain. It's 80 over 67.
Yeah, look at that.
That's a summer day.
Yeah, that's a function of the stream that you were talking about earlier, and this widespread high 60 dew points. The highest one I see is 68, and another 68 across the border in Texas and far southwestern Louisiana. So that's a beautiful day. Yeah, that's not high. Okay.
And also, it's interesting from that station eastward into the Panhandle, where you have these dew points in the low to mid 60s, even higher 60s. That's where you saw the cumuliform clouds. But over Florida, dew points are still a bit lower. It's a little bit, well, I wouldn't say cooler, but lower. It's slightly drier there. Yeah. The boundary layer isn't really deep enough, I guess, to create the cumulus clouds.
Yeah, that's right.
So the peninsula.
Let's head up to the northwest, where the only other precipitation on the map showed up. We have a little bit down here in southern New Mexico, light rain in the southern stations in New Mexico, and then up in the Puget Sound, it's just foggy or something at Bellingham, raining along the coast, not raining at Olympia, and snowing in Spokane, and then moderate snow right on the border of Idaho and Montana. So that's pretty good. It doesn't show up so well on the radar, of course, and then lighter snows in western Oregon and central Idaho. But by and large, a pretty nice day across the country. You see a lot of open circles on the station blocks, and so a lot of places are enjoying some sunshine. Just to our south and southeast, that is not the case, but we're not going to complain. So it's not, I suspect the temperature doesn't move much today. 23 with sunshine, but upstream 17, so cold advection against sunshine. By about noontime, the balance pretty much an even split. Let's take a look at 500 millibar map. And here we are at 12Z this morning, so about 7 a.m. local time. Very strong baroclinic zone at 500 millibars, roughly in the position of our precipitation band at this current time from western PA all the way down to Arkansas. Maybe it's moved a little bit further to the south and east since then. So this is likely the upper tropospheric portion of the baroclinic zone that we might be able to trace all the way down to the ground. So this is the deep cold frontal structure, is my guess. Very strong cold advection on the western edge, and then more or less zero temperature advection along the leading isotherm, which is minus 15. And so one has differential temperature advection at 500 millibars in this region, coincident with the strongest winds at 500 millibars. That's not surprising. And one gets the idea that there's a thermally direct circulation induced along fairly reasonable length of that baroclinic zone, and it coincides exactly with our precipitation band. So that's one feature of interest. Here's the deep reflection of the extraordinary cold air at 850 millibars, and it's also extraordinary cold at 500 millibars. Minus 51 at that station in the archipelago, minus 50 here in, I forget what this part of the territory is called now, but minus 50 and minus 51. I don't think you see colder than that at 500 millivolts. Even in the depths of the winter, anywhere that I've seen on our maps of the western part of the northern hemisphere like this, you just never see it colder than that. So that's desperately cold, and it's but only a 7 degree or so Celsius lapse rate from there down to 850. So for about, and that's 4.6 kilometers above the surface, the 850 is probably about 900 meters. So about 3.5 or so kilometers, you have almost no temperature contrast. So very stable, cold air, low tropopause. Great.
You mentioned it's extremely cold as you keep going up from there.
At the same locations and latitudes.
Even at about 30 kilometers, it's extremely cold.
Is that right?
Yeah. So this goes all the way up, and surrounding that is the polar night jet, which is displaced off the equator, and it's running between Lake Superior and the Hudson Bay, is where a polar night jet is right now.
Is it strongly curved like this?
Yeah, it's curved right around it. There's a trough of it curved
Yeah.
down, and it's meeting the what appears to be a subtropical jet. It's maximized at about 11.5 kilometers above the ground with tropical potential vortices. It's coming in across
Well, over in this region,
Minnesota,
right? Oh,
in Minnesota
Minnesota.
into there and meeting with it. So it's kind of merging with that, so that there's basically a cold baroclinic gradient to the north, extending down with a little weakening, let's say between about 18 and between 18 and 14 kilometers. The baroclinic gradient's a little weaker. But once you get above 18 kilometers, it just keeps getting more cold to the north. So this, you look at the ice attacks with that jet stream, and the ice attacks at about 30 knots extend all the way down from 25, 30 kilometers above the ground, all the way down into the subtropical jet region and into the polar jet region. And then there's a baroclinic zone coming right to the ground. So basically, this is a continuous system all the way up. And what's also interesting is how the subtropical jet is plugged into that. So there's basically a direct Hadley circulation with the pole going
what
on
should we
right
look
now
at to demonstrate
over there.
that? What should we look at to demonstrate that?
What's that?
What should we look at to show that?
I have a cross section in my pocket, but I didn't make anything electronic to show you. But if you look at the jet streams, you can see it on that plot I have.
Monitoring the jet, you know, so.
Just look at my jet stream plot.
So which one?
Just take the top 61. Yeah. Okay, you can see that green jet right there is the polar night jet. Stop at the
This.
very first frame, yeah, which is now.
This would be right now. We can see.
All right, so
Okay, yeah.
this here is the polar night jet.
That's a polar night jet.
Not so strongly curved as I thought. I thought that cold air, and we'll have to look at 850 milliwatt. I thought it was this was the polar vortex effectively at this late stage of the season. And the jet seems a little bit less curved than the vortex.
I think it is that when you're looking at that jet, this plot, three-dimensional surface goes up to 25 kilometers. And so you're looking down inside those ice attacks.
Okay.
You're looking through the ice attacks and you're looking down into the lower part. And what you're seeing below it is the subtropical jet that you can see coming across the Pacific.
That's this here, right?
Yeah, and it's kind of extended at other intervals all the way off the coast of Baja California and into the main body of it in the Pacific.
And then the blue is a polar jet.
If there is a polar jet, whatever you want to call it, it's kind of like, I
You
mean,
never think there's a polar jet.
I mean,
Obviously a polar jet.
it's a degraded subtropical jet, but yeah, we will call it a polar jet.
Okay.
But the maximum of that jet is at 11.5 kilometers, so it's way higher than a polar jet. usually.
Oh, okay, all right. So we can assess some of those characteristics on the set of charts too. We'll see how they correspond.
And when
Earlier in
I
the week, I thought there was a clear separation. I don't know about now. I hadn't looked at it.
I don't know, and then I did another thing of the potential, the velocity potential.
Uh-huh.
At 13, 14 kilometers, I noticed the Walker circulation shifted to the east, so it's kind of maximizing in the western to central Pacific, where it normally would maximize toward the maritime continent. So we're getting a lot of upward motion where you see all that pink subtropical jet are off the coast of Asia.
Right in here.
That's being pushed up by this Walker circulation off the west coast or east coast of Asia.
So it's right here as
Yeah.
opposed to over here.
It's being fed directly by this Walker circulation coming in. You also notice in the Atlantic, there's an active secondary east-west deep circulation, and you got that very strong subtropical jet in the just in the North Atlantic. It's just north of the equator. You see it?
This right here.
Yeah, it's actually at about 15 degrees north, fairly far south, and there's a strong upward maximum velocity potential now towards South America in the southern hemisphere, which is feeding that heavy circulation down there. So this is another enhanced region of upward motion on the globe in competition a little bit with the Walker circulation to the west. And so there's another subtropical jet formation which you see going all the way across Africa and moving in toward Asia on the right side of that plot. But I think what's interesting is this polar night jet. A couple days ago, I saw the easterly winds just north of that at the pole. So this was a complete circulation that moved off the pole.
Yeah, that's not surprising because that's how it shows up at 850. And at 500, as we just saw, it is a local cold spot and it's got really no radius. So it's the whole polar vortex in the lower troposphere anyway, sitting right there. Yeah, that's really interesting. Okay, so.
And so you don't see a polar night jet in Asia because it's moved off in our hemisphere.
Yeah, so this is the whole game. Yeah. So let's go back to 500 millibars if we could. Okay, so, and we'll pay attention to what we're seeing at various other levels, but especially in association with the cold pool here. And one more thing I want to say about the map, and that is, here is a really interesting feature. It's 105 knot wind off the Queen Charlotte Islands here off the coast of British Columbia. Local 105 knot winds, and then weaker to the north and weaker to the south, and certainly weaker to the east. So there's really strong horizontal shear, and there's a little bit of curvature there north of, or in the central coast of British Columbia. Coincident with a really intense horizontal temperature contrast, which may be underdrawn here in the computer analysis, probably is. This is the -20 isotherm. And look at how it goes through -26. It's confused along the coast. -37, -38 in the interior. So very cold horizontal temperature contrast. I mean, a very cold air in the interior, so with a huge temperature contrast here. Maybe it's just beginning to set up for the development of a depression in the tropopause. So this will be an interesting feature to keep one's eye on in the forecast. Sometimes they do undergo some upper frontogenesis for a period, and then they don't really end up connecting in any other structure, and they become a linear vortex strip, and they're not really particularly weather potent. But that's not always the case.
Yeah, this one looks, we'll see in the forecast, actually, about 36 hours may give us a little bit of vision.
Oh, good. Okay, so there's something upstream that maybe we're seeing here now that it actually does have some bearing on what comes next. That's interesting. Okay, let's go to 300 millibars first, Pete. And here is a jet that's at 300. It's always difficult to distinguish what's what in terms of polar or subtropical jet. There's a little bit of a wind speed maxima here over Lake Winnipeg, which makes me wonder if we're not going to see most of this at 200 millibars and not so much of it in this portion at a next higher level. But these are strong wind speeds. These are 177 knots at the core, right over the thumb of Michigan. So that's a pretty intense jet.
I think what you're seeing over Winnipeg might be a downward extension of polar night jet.
Yeah, which could be.
And this other one is a subtropical jet coming up, the big one there.
Yeah, okay. You refuse to use the words polar jet. You just won't use the word.
Polar jets are just old subtropical jets.
What?
There's really only two. There's
Okay.
the subtropicals, the system of subtropical jets and the polar night jet.
So for those tuning in, you'll understand how we have so much fun here on Friday, because and it really is. It's a crock pot for ideas. And so we're constantly battling about things and in perfect spirit of scientific anonymity. So,
It's in a nice mix of ideas in a crock pot, not
not a crack
crock
pot.
pot, not a crack pot. Right.
Yeah. So you're right, though, Greg. One way to distinguish here is to go to a higher level. Let's try 200. Let's just skip 250 and go right to 200. And this does start to look like purely a subtropical jet. And then this thing here, let's go to 100 and see that now this should still show up more intensely.
I think it
right?
will.
Okay, let's see if it does. And it does.
Oh my God.
Okay, so it's really interesting.
See what I'm saying?
Yeah, now I see what he's saying. Okay, and notice how the subtropical jet part of it is getting weaker. So you're above the jet core of the subtropical jet. You're getting closer to the core of the polar night jet.
He's done just two jets.
Yeah, that's right. I see that. I'll agree with you on this today. But look at how. And then I'll also point out that your depiction on the Mercator projection really takes away how strongly curved this is. Because look at how strongly curved it is. Southern tip of Greenland to
Yeah, if you look at it on
that's a
polar
sharp,
stereographic, you see.
that's sharp curvature. So I was misled even from that perspective. So this really does look like a displacement of the polar vortex to the southern archipelago, northern Hudson Bay, and it's very small in scale. This might be the end of the winter. So, Michael, what were you gonna say? So Greg wins this week. Last week I won with the snow. We're still waiting for a Morgan victory. I think it's, but it might be coming. But it might be coming. Okay, so
That's how the hurricane season is.
now the last thing I want to say is I want to just go. Let's go to 850 or 700 first. 700 first because 850 is so ugly on these guys. 700 is a little bit higher, and you see sort of the baroclinicity associated with our lower tropospheric front is fairly diffuse here. It doesn't look any stronger here than it did at 500, and so I think if we had a hand analysis of 850, you'd probably see a stronger baroclinic zone. We'll show that in the actual model analyses as opposed to these. In color, I think you see a little bit more of the structure than you do just in this map. But the baroclinicity, the leading edge of the cold air convection is about right there from southern Pennsylvania down to central Oklahoma. And that, again, corresponds nicely at 12Z with where the precipitation band was. So it's a really nice dynamical structure.
And some confluence along that.
Yeah, that's true also. There's confluence along the warm edge. That's also obvious in the geostrophic flow. And notice how cold it is, minus 42 at 700 millibars. So again, you're getting that's actually warming up. I think, let's go to 850 and see what the temperature is at this station at 850. Oh, I guess it's minus 38 here. So earlier, minus 42 is right in the middle. So very gradual temperature changes as you go up with height. So there's a very, very low tropopause there. And it is, as Greg points out, this is the polar vortex. And ringing it is the polar night jet. And sliding up from the tropics, consistent with what we saw in the clouds and the satellite, is something of a subtropical component of the jet stream. And they're confluent over southern Quebec and New England at this time. Downstream of that confluence, a little bit of a disturbance
I
developing.
think what I want to point out is the way that subtropical jet seems to be fed from the subtropical jet across the central Pacific, which is connected into that displaced Walker circulation. I think this is suggestive of the La Nina type circulation, where in the La Nina circulation you tend to have that very strong Pacific water circulation.
And that's,
Although, I don't know, maybe in the La Nina circulation it should be displacing.
yeah, right. I would have thought it was
I don't know.
west.
Well,
I would have thought.
I know maybe I take that back. I don't know. But we do have very strong eastward displaced water circulation.
Yeah, so the reasons underlying it are
It's
interesting.
almost like a El Nino then.
Yeah, right.
Yeah.
The warm water moves across the central part of the ocean basin, doesn't it?
I don't think it's that far displaced. And I mean, you can have movement of heating anomalies within a La Nina pattern. I don't think we have.
Yeah, it is displaced from where normally I see it more intersecting the coast of Asia. But it is displaced more toward the central Pacific. Right?
And that's far in the tropics, because there are a lot of subtropical troughs right now in the Pacific, kind of littering. There's a big anticyclone to the north and these subtropical troughs, but that's probably not impacting the velocity potential if that's in the tropics, right?
Well-
Or kind of the enhanced the convection.
I don't know.
Well, the last thing I want to show is, let's go to the model analyses at 12D. In the GFS would be preferred. And then let's take a look at the, if we can, let's get the whole hemisphere picture. So not the 104, because it's hard to do. Let's just take a look at the 12Z analysis. If it's in. If it's not, we'll use 060.
Or the 12Z.
I just want the analysis of whatever time we do that. Okay, so yeah, this is 12Z this morning. So this is a vivid testimony. So here's the whole northern hemisphere, of course, the United States right here. This is vivid testimony to the fact that that's where the cold polar vortex sits. It's completely split off from the weaker component of it that's over here. I'm trying to find exactly where we are. That's Japan, and here's Korea. So this is out of Siberia and Mongolia. So here we are in Siberia, Mongolia. The really central region of the coldest air is right over the northern, the central Canadian archipelago, northern part of Hudson Bay, and it stands out like a sore thumb. And the warm edge of that is right where we have our precipitation band, and several different waves are going to form along this baroclinic zone on the southern trailing end of the vortex. Now, the -5 isotherm is about this third shade of blue, so that's not going to help you very much, but it's somewhere in this range. So this is about the periphery of the -5 air. And so what I've been doing for a number of years is tracing the aerial extent of that -5 air every single day through the whole winter, December, January, and February. And I can show you what this winter is looking like in the daily time series of the aerial extent of the -5 band compared to long-term average and its standard deviation. And that's on the right down here. And so here it is. So the blue line is the daily average from 1948-49 to 2013-14. So it's a long-term average. And then plus and minus 1 standard deviation shaded in gray. And then the red line is the daily time series from the winter 2017-18. Goes all the way to February 15th. And so far this year, compared to the other 69 in the time series from the NCEP reanalysis data, this is the 18th warmest, that is smallest aggregate area of the 850 millibar -5 air in that 70-year time series. So it's 18th warmest. It's sort of mid-one. We've had, in the recent past, 2013, 14, and 14, 15, were back-to-back smallest areas of all time. So warmest year.
So you mean warmest average over the whole winter? Or?
Yeah, every day's departure from the average added up.
Yeah.
Yeah, so.
But right now, we're near average.
Right now, we're a little bit above average. Today, we're actually at average. A couple of days ago, we were above it. But the long-term integration from December 1st and 15th to December gives us the 18th warmest such, 75-day long period in the 70-year time series, and 15 of the 20th warmest up until this date in the winter have occurred since 2000 and 2001. And there's only been 17 years since 2000 and 2001. So almost every one of those years has found its way into the top 15 or the top 20, warmest of all time by this measure. So we're really, every single year it's bearing out that we're seeing a dramatic change in the high latitude production of cold air. And I don't see any way to argue this except by radiation change, a change in the radiation balance. And so we see a beautiful signal this year. We're going to end up, one thing that's interesting about this year with only 13 days to go, we've never had 4 straight years which have the same tendency of either an slight increase in the aerial extent over the whole year or a decrease. If this increases, if this is bigger than last year, it'll be the first time we've been a 4-year streak in the 70-year time series. So that's interesting, but I don't know much about streak statistics, but it's nonetheless interesting.
Right, so the fact that we're below that blue curve indicates that hemispherically we're warmer, right?
Yeah, that's a warmer period,
So
that is too. And
it's really interesting, and it just goes to this notion of thinking locally or globally about the temperature. That period we had in late December through early January,
Right
which
about
was pretty severely cold for us here in Madison, was hemispheric-wide pretty warm.
in fact, included the only day so far this winter that's what I characterize as an extreme warm day, the day where the actual area extent is 2 standard deviations below or more of the daily average. It's the only day of the entire season that's had one of those. Last year we had 3 or 4. So
Why is
yeah,
it if you compare this with the global average temperatures, they've been saying the last few years have been the warmest.
Mhm.
But you're saying you're top 15 or 20 warmer, in the top 10 or something.
yeah, it's pretty much the same statement as it turns out. So 15 of the last 20 of the 20 warmest years up to February 15th by this measure have occurred since 2001.
Is the warmest year occurred?
The warmest years, yeah.
So that is consistent.
It's
with-
very consistent, yeah, it's in hand to glove almost. And yet this is free atmosphere, so you don't have to worry about whether you move the thermometer from Science Hall to Dane County Regional or anything like that. This is free atmosphere. And that's nice, so that's all I have.
Thanks, John. Want to start off with the hazard page? Thanks, John. So now we're going to be looking at the sort of outlook. First of all, before we focus in on the Madison weather and perhaps the weather in Daytona, Florida, we'll look at the U.S. sort of hazards outlook put out by the Climate Prediction Center. And this is the first for the period next 3 to 7 days. And there's going to be a chance for much below normal temperatures over western United States and the northern and central plains. And also this fairly conspicuous area of heavy rain that's expected over the period, centered over the southeast United States and the, that looks like the south central United States, the Tennessee Valley, Ohio Valley, and the southern parts of the Midwest. So really wet period, and I believe that's in part due to this established lower tropospheric subtropical ridge and the flow around it from the Gulf of Mexico and ultimately the Caribbean as you go through trajectory analyses, bringing that very moist, humid air into our moisture-laden area into the central United States and interacting with some paragenicity producing the precipitation. So it's going to be a wet period. If we scroll down just a bit, it's a little bit more clearly. In these 2 periods from the 20th to 21st, And then from the 18th to the 19th, this is 18th to 19th, 20th, 21st becomes more widespread. In the background of relatively dry conditions, this is much below average much below average precipitation in these regions. So severe drought is indicated in the brown areas on this map. You can see for this winter period, it's been extremely dry. And it's surprising it doesn't extend all the way up into areas like the Lake Tahoe area, but they're also near Reno, Nevada. They've also experienced a fairly snow-deprived winter thus far. So lake levels are down. It's dry across much of the western United States, but the severe drought of these areas indicated drought. So some alleviation of that in parts of Missouri and Arkansas over the next week ahead. This is a really neat page because it'll detail, if you scroll down further, all the regions where they're expecting precipitation, sort of a nice discussion of some of the impacts expected, almost day by day through the period. But we're not going to put so much of the detailed summary here.
It's like the Farmer's Almanac, except accurate.
Right.
Yeah.
There's something behind this, the science behind this. We can also see how this actually varies. Let's go back and focus initially further closer to home. Look at the MM5 forecast. We'll start off with our meteorogram. Everyone knows that's how we say it. Here in Madison, meteorogram, not meteogram. It shows our temperature and dew point forecast, as well as the precipitation, accumulated precipitation, parallel precipitation on these maps. So mild, temperatures mild, getting a bit more mild over the course of the weekend. Again, I'm not going to put explicit values, but the trend is upward, and the moisture dew points also increasing somewhat. That's not going to be too much of an issue. But we do have this curious feature sometime between 18Z tomorrow and 0Z tomorrow evening of a little bit of precipitation, less than maybe just a couple hundredths of an inch, so maybe a slight sprinkle or something that's forecast by this model. The GFS also indicates a little bit of precipitation as well. Let's take a look at, first in our time height section, what's going on. And so this time height section starts from 12Z today all the way out to 0Z on Monday, so Sunday evening at 6 p.m. Again, the yellow here indicates the potential temperature. Green is the dynamic tropopause indicated by the 1.5 potential vorticity surface. Blue contours here indicate vertical motion. This is the pressure vertical motion omega, but what's plotted is minus omega, so solid contours indicate upward motion, dash contours sinking motion. And you can see the really interesting thing is early in the period we have a relatively low dynamic tropopause over us, but it rapidly ascends, perhaps as the jet maybe moves just a little bit further to the north, going to this broad, low PD environment in the upper troposphere. Along comes that short wave. This is the structure we'll see when we look at the time series of the maps, the looping of the maps. You get this dip in the dynamic tropopause. It's a short wave passing by. It has a nice classic shape. As it passes by, the column cools beneath it. Here's our cold zone beneath it. Slightly warmer temperatures above this positive PD anomaly. You have the ascent as it approaches and the descent as it moves away. And as the air is ascending and it's cooling through adiabatic expansion, we're going to get the relative humidities increasing. I believe it's this feature as it passes by that gives us just that brief shot at some light precipitation through following its passage. And once it's passed, some subsidence occurs, things dry out, and you get some other mechanism that's occurring, like strong warm advection near the end of this period, which could lead to more precipitation if it's moist enough in the lower troposphere.
It's really interesting how the bundle of isotopes from like 279 to 270 put a cap on the whole boundary layer. There's no way that any of this stuff is really going to ingest very much air from the lower part of the atmosphere.
That's an excellent point right there. So this is everything that's going on with this approaching upper trough. We'll see it in the analysis. Is really mid-troposphere is sort of disconnected from the lower troposphere. Even as well mixed there forms tomorrow afternoon. So we're going to see perhaps some clouds, maybe a slight chance of precipitation. We can look at again some other model forecasts, but there's a threat, just a few sprinkles. Now, we'll acknowledge last week we were talking about a pretty dry weekend. It was pretty boring, but I was totally shocked on Sunday morning to wake up to an inch or maybe even more of snow. I think it's pretty likely we're going to escape that condition on this coming weekend. Anyway, let's take a look now at some of the horizontal maps that we have. We'll start off with the PV at 315 and 325K. So the feature that John was looking at earlier is this potential vorticity maxima that's located over British Columbia, north and central Washington State. We're going to watch in the forecast as we animate this basically propagating, being advected to the southeast across the central part of the United States and then across us by 36 hours. Also, you can see, this is consistent with some of the maps that John and Greg were talking about earlier, this whole lower troposphere, or the southern part of the United States, south of this significant vorticity gradient, or air that's characterized, the tropospheric air, maybe even more tropical air mass, at least in the upper troposphere, these very low uniform values of potential vorticity that extend south of this the main jet. You can see where the winds increase, and where that sharp PV gradient is also where you see the jet. That's nice and consistent with what we expect to see this time. But this is the feature we're going to watch as it evolves, and we'll look at the animation of this, and then take a couple of individual maps. So let's do the GIF, I think, of the 315 to 325. We'll look at two different layers as well. The feature, actually, there it is. It passes by us, continues on. See one more loop of that. By, it's moving way too fast. I have to work on slowing it down. Yeah, we can't do that. I guess we'll yeah. Let's stop that. And we're going to just go to the 12-hour forecast. Okay, so here's that feature that's moved out of the northwest. In fact, it's really this feature right here. So we can go forward. I'll just hold this right here and advance that. 24 hours. Move southeastward. Here it is. The 12 axis way back here, and we'll go ahead another 12 hours. Be right over us at 36 hours. Here. So nice progression of this. So this was the time period where we had the lowest, roughly the lowest downward undulation or protrusion of the dynamic tropopaules over us. It was when we had the trough axis over us. So it's really consistent with what we saw in the time height section. And it's just preceding this time period when we have the ascent occurring, the column pulling off, and the precipitation that was forecast in our meteorogram. We saw that showing up. This is really a very boring weather pattern as this feature goes by. We'll see that this doesn't have significant curvature at 500 millibars. Let's actually go back a quick.
It's like a recession too of the high PV back to higher isotropic levels.
Yeah.
As it comes across, which makes it even more boring.
So 500 millibars, 36 hours. That time.
So,
Here's the trough. You can see a maximum in vorticity near the southern tip of this, but again, this doesn't have significant curvature. So as strongly as it was well depicted in the time height section, and maybe because of its speed and motion, this is not a very strong upper trough. Yeah. The change in curvature from cyclonic to anticyclonic downstream of it is so weak that you're not going to expect this to have really robust dipoles of divergence and convergence ahead divergence downstream of the upper trough. But in any case, if there is a trough, it'll be enough to give us some clouds and maybe just eke out a little light precipitation. Far southeastern part of the United States is still under the control of a broad ridge, so that's not going to be too impactful weather-wise. And maybe we're beginning to see the arrival of this deeper trough off the west coast of the United States might suggest the beginning of some inclement weather in the Pacific Northwest and cooler temperatures as this trough begins to settle in. Let's go ahead at 500 millibars, just a couple more steps ahead to 48 hours. And really deep, very impressive trough with a westerly flow over us. And that westerly flow across the Rocky Mountains with subsidence gravity suggests we're going to begin to warm back up. And that might be the leading edge of the warm advection we saw in the time height section at the very end of the period at 60 hours. Might be the beginning of it's a temporary warm up for us. Let's go to 60 hours at 500 millibars.
that confluence zone from Montana and Alberta over to the Great Lakes is a vortex crusher.
Great leader.
Yeah.
Right.
These things
really nice confluence. So any vorticity, even it's nicely balled up like this, it enters that region and gets strained out.
Yeah.
And not going to be very productive weather-wise. Although if there's any variability there, you could begin to get.
You can get transversal. Yeah,
effects.
you don't get any cyclogenesis.
Right. So let's see. That's at 60 hours. Again, that flow was westerly, a little bit more southwesterly, still favorable for us to get significant downslope to our west. We see that 800 hours and a significant warm up. I think before this is settled in. You see this ridge or this trough in vorticity really beginning to trough in the height field, deepening over the western United States, and that's consistent with that colder period and wetter period they're expecting out of the western part of the United States. Okay, and you'll notice this subtropical ridge is at 500 millibars. It's not in the lower troposphere. But again, this flow from the at 500 millibars, if you were to follow air parcels, since it's so persistent, westward moving and then turning cyclonically or anticyclonically around the ridge, back into the southeastern United States. It'll be more apparent when we look at lower levels, but the stage is being set for perhaps a wet period. All right, let's go back to the potential vorticity. I know this, we'll go 12, 18, and 24 hours, just to show you a couple things that are kind of neat. Notice the colors here. Again, these are lower guides of PV are the very light blue, and then dark blue is a little bit higher PV, and then even darker, higher. So let's watch this as we go from 12 hours, 18 hours. Okay. So potential vorticity is supposed to be conserved, or it is conserved, right? It's not supposed to be. It will be conserved in the absence of adiabatic and frictional effects. The fact that we went from no dark blue in the map before to this darker blue here indicates that some process going on that's associated with late heat release or friction. Now I contend that we're probably well above the boundary layer, so this is the frictional generation of PV. We go ahead another click time, just that getting even larger. Yeah, this shouldn't be changing. If everything were perfectly conserved, it would just simply be affecting, transporting along with the wind these PV structures. So the fact that this is increasing suggestive of diabatic heating. How can we confirm that? Well, if it's diabatic heating and there's precipitation occurring at a level above this, we should see a reduction in potential vorticity above this level during the same time period. So I'm going to keep the cursor here, or just remember we're between Oklahoma and Arkansas. Let's go back and look just 10K up for the same time period, start at 12. Right? So we have these light blues and then darker blues. Let's go ahead one more click. Ahead. Oh, on the road, right. Getting a little bit of reduction here. Let's go ahead one more click for time-wise. And we get this expanding area right here. And so this is consistent. You may say, well, they're displaced a little bit. The higher PV was generated a little bit further to the south than the reduction we saw further to the north. This is getting out ahead of it. A couple ways to interpret that. If we're looking at this map, the vorticity vector is not going to be perfectly vertical. It's going to have some tilt to it. And so remember, the tendency of potential vorticity is the diabatic heating gradient along the direction of the absolute vorticity vector. Because we have this jet to the north, it's going to be tilted a little bit back toward the jet. And so we're going to get a reduction of PV to the south, an increase in PV to the south at lower levels, reduction at upper levels. We have strong shear in this region, and so that's going to get ejected downstream to lower PV. And so you get them separated a little bit, but they're going to be displaced purely because the vorticity vector itself isn't perfectly vertical. And so when we have this reduction in PV here, I'll keep the cursor here if we go back to the other time. At the same time, sorry, but at the level down here is where we have the increase in a little bit further downstream. So I think once you've reduced it, when the winds are stronger aloft, it's going to get affected faster downstream. That's my suggestion. But where's the precipitation? Let's take a look. Go from 12 to 24 hours for this time period. I believe it's going to be this blob here is the one that's going to be, as the model's going to spin up. Let's just watch this. That up there, unfortunately, Oklahoma and Arkansas region. Then it begins to spread. And this time it's going to begin to see the largest reduction down there. So this is where we're getting the diabatic heating. Make sure you speak up. Yeah, that's where we're getting the diabatic heating and the reduction of PV down in the southeastern part of the United States. I don't think this is not the big precipitation event that's going to occur further down the road, but again, at least one pulse of it. A couple other things to watch. Getting back to our weather here in the Madison area, this is the 24 hours. Let's go ahead to 36 hours and check out what's going on the surface. Goes by. This is the time we have the trough axis just about over us. Here's the precipitation downstream of that trough axis. Very light precipitation, if any. Again, that's questionable. And then you can see the dip in the thickness contours. This is the coldest air. And then once this moves a little bit further downstream, we'll begin to clear up. We can diagnose these patterns of assumed vertical motion and inferred vertical motion for the precipitation by looking at the Q vector diagnostic at this time. Let's go to the Q vectors at 36 hours. See a nice couplet around this upper trough. This is the mid-troposphere. There's a region of ascent and Q vector convergence here, divergence just to its west. And we have the trough vectors, recall, is down here, at 500 millibars, the trough was stronger to the south, if you recall that. This is one that's just passing by us. And then this other area that's out over West Virginia where we see some convective convergence. Let's look at the omega field at the same time.
Funny that there's a bit of a surface depression on the southern end of that trough over us that's disconnected, or in the wrong phase relationship with the other trough.
So it's not going to be able to
Yeah,
develop.
not going to develop.
But here's a sort of stringy region of ascent back into Indiana, and then here's the broad area of subsidence. In Q-vector diagnostics, you want to integrate that and solve the omega equation like John does on his weather maps or on his website. To fully, here's the other area of strong Q-vector convergence where we saw the ascent, where we now diagnose or see from the model forecast significant ascent over West Virginia. So those diagnostics work pretty well. All right, so I want to go away from these maps and just do a loop for the surface. There's a big event, I guess, going on in Daytona 500 over Sunday. No, it's Saturday. A request from someone on Facebook.
Rob Holmes on Facebook wanted to know about the Daytona 500 forecast Sunday at 3 o'clock Eastern time.
I won't get specific because I haven't looked a lot at this. I'm going to ignore this precipitation. I don't believe it's actually good. We'll look at the GFS just to verify that, but I'd assume probably decent weather down there over the course of the weekend.
Yeah.
It's, low, middle upper 70s and lows in the 60s. About what they've been experiencing the last couple of days. So let's go to the GFS just to get a good perspective. Pivotal. I don't have that up yet. And we'll go to 6 hours. We can step through this. Go to precip type and rate. One nice thing is the maps are coming up. And we had that frontal passage yesterday. We had a nice mild day. Here's the rain that's occurring to our southeast. Once that front went through, I was thinking today would be it's definitely colder today. And as John said, the insulation is losing to the cold convection that's over us. But it's really short-lived. I mean, look at how stubby this ridge is. And the warm convection already started west of us.
Yeah, we saw that in the southwesterlies all across Minnesota and
Yeah.
Dakotas, yeah.
So this is gonna be short-lived. So let's step forward. And I hope I wasn't wrong, Rob, about the precip. You can see how far this front goes and the precip associated with it. Nicely dries out. Here's warm advection coming in. We can go, let's go to 18 hours before. This ridge, as John was mentioning, is going to fade off to the southeast. So watch that. Just like you saw in the MN5 forecast, here's the precip beginning to wind up towards over parts of Texas and New Mexico. So 30 hours before forecast, so tomorrow, late afternoon, evening. Here's the rain moving into the mid-Atlantic. And for us, we briefly got into warm advection. Looks like some more cold advection coming in tomorrow evening at that upper trough field line. This is actually not a
Topsy-turvy.
Short-lived warm advection, short-lived cold advection. For cold advection, now warm advection coming in, that gets cut off by tomorrow. Interestingly, for the mid-Atlantic, this is going to be a big forecast issue from, I guess, DC northward into Pennsylvania. We have this precipitation that's headed toward this northeast. It's still cold here. I mean, the thicknesses aren't, super cold for snow, but it's certainly going to be an ice storm set up for northern Maryland and southern Pennsylvania. Let's go ahead and click 36 hours. Begins to set up. And you can see, even with these modestly cold low thicknesses, it's 546. It's still decent. You can perhaps get snow from that, but you can see from areas just to the northwest of Roanoke through Charlottesville, Virginia, it's like an ice storm, and then more just frozen precipitation. If this typical interpretation of precip type is correct, with snow in western and central Maryland and southern Pennsylvania. But for us, this is the 36 hours, the time that trough is supposed to go by. We use the wind shift. It's very light precipitation, nothing over us. So decent weekend. And that's Sunday at 0. Let's go ahead to 48 hours. So good morning. Again, that cyclone is now well off the east coast. Again, the southeastern United States, particularly the eastern coast of Florida, looks pretty worry-free in terms of precipitation and light winds. Those are the conditions expected down in Florida. For us, here comes really strong warm advection just to our south and west. Let's go to 72 hours Monday morning.
Florida's still pretty dry.
Yeah, it looks like it's been dry during that period, but key thing here is here's the first big round of precipitation for the southeast United States, not very well organized at this point. But just notice this, the flow, the geostrophic flow at this point around that subtropical ridge. That ridge that was over us today has now moved off to the southeastern United States and offshore, kind of merged with the pre-existing one. You have this broad southerly flow. Here's our baroclinic zone. Here's the flow of relatively moist air from the tropics or from the subtropics into the central part of the United States to the stage for some rain. But for us, we're going to be mild enough perhaps for just liquid precipitation. We have to look at the surface temperatures to make sure we're not going to get ice. Let's click here. I think you might be able to get a sounding. Right. That is right up there. Surface temperature is 33. So that's, if we're to get precipitation, we perhaps liquid at this particular time.
I'm nervous about an hour or two later when it looks like there's much colder air moving in. Yeah, you're going to end up with freezing rain threat.
Good, so I guess the surface, you're not going to change the temperature here too much, right? It's going to be a lot, but you could.
Well, I think with the whole structure of the weather system kind of organizing, pulling down, it might be colder everywhere.
Okay.
Yeah, I don't know though. You might be right.
Yeah, let's click off that and. Or actually, can we advance this? 75 hours perhaps, or 78.
Oh, it's even warmer.
Yeah, so actually more warm still.
Wow.
And we moisten this column up, so any chance of frozen precipitation, I guess, at least if this forecast is to be believed, is going to diminish and will actually warm up at the surface. But even I think the 6 hours before, there's still a threat maybe of some frozen. Let's quit this. Go back to the maps at the same time. Okay, at 72 hours, let's go to 90 hours. Get through this quickly, we're running out of time. So still lots of precipitation. And again, this broad ridge, again, it looks accentuatedly in terms of its intensity, looks really impressive, but this is because we use 2 millibars per contour. For everyone online, everyone here, don't do that. Keep it at 4 hectopascal. All right. But this really sort of disjointed precip. Here we're going to be sort of in a dryish slot, nothing traditional dry slot, but rain to our south, snow to our north, and we're just, okay. Yeah. One. And we just jump ahead to 120 hours, 5 days out, which get us to Wednesday morning. Cool. Ugly. Again, that baroclinic zone, and that persistence of tropical ridge that's sort of locked in place. Along it, we're going to get this precipitation just continuing. This is, again, a good setup for a lengthy period of precip. It's a slow-moving boundary on the western periphery of the subtropical ridge.
It's a strong shearing frontogenesis region between 2 big anticyclone circulations.
To get you the baroclinicity of the shearing during frontogenesis. If we look at the cumulative precip for the first 120 hours, the forecast, wow. Looking at over 4 inches, 5 inches of rain in Arkansas, that region. A little bit of light precip along the east coast of Florida. Check when that occurs. I guess the bottom line is, we're going to be, sandwiched between 2 areas of precipitation early in the week. Rain to our south, some snow to our north, and going to be some light precip. So if we just wanted to see the various forecast, let's say from 12 hours ago, for the same time period, about the same.
Pretty solid, though.
Yeah.
I'd say, cartoonish wise, it's about the same.
Yeah, the heavier to the southeast and the heavier precipitation to our northwest. I want to just go back and look at Goldilocks winds at 6 hours in between.
Tell your mama, tell your pa it's going to rain in Arkansas.
Right. Did you make that up?
No, that's Ray Charles.
Oh.
I did.
All right. You get music, you get weather, everything. Get the greatest hits. Okay. And I always like to do this. It annoys everyone, but I'll do it anyway. We'll go to 384 hours, the end of the forecast period. This is the total cumulative precipitation. And remember those areas that were, whoa, that's insane. Really wet period. And if we were to loop this, I think you would see this persistent flow around the subtropical anticyclone transporting moisture.
This is interesting. Is this the time of year where, the subtropical anticyclone begins to establish itself, late winter, early spring?
And you get the precip on the northwest side that helps to reinforce it.
Right, and you keep that reinforces it, and you keep on getting the drainage of cold air in the form of anticyclones out of Arctic Canada. This is the time of year where this is probably most common.
I think you're right. And also, maybe it looks like might be also in the fall.
Yeah, right, it's almost six
Very
or 8
similar,
months
right.
later, yeah, that's probably right.
So there's a nice relationship. So that might be an interesting project.
It would be
We'll probably
really
look
interesting,
at
wouldn't
just
it?
to see the, what helps to establish this and what helps to reinforce it. I mean, the precipitation that's occurring here, at least in the upper troposphere, is gonna help build a ridge at upper level a little bit further to the north.
Yeah.
To displace it, but the relationship between what helps this to persist and the weather systems that come in from the higher latitudes reinforcing it would be an interesting
Yeah.
research question. We could, as one last thing, 120 hours, and rather than talking about, well, the moisture is being transported, can we see in the, it's not this one, the upper moisture, and look at, this is relative humidity, not a mixing ratio, but let's go to 850 or 700. 850. But you can see this flow from the all of Mexico northward. You can see where it's interacting with this wind shift, which is our baroclinic zone, also flows to the baroclinic zone, and the frontogenesis, which is going to help to wring out that moisture with a circulation on the warm side of that baroclinic zone. We're going to go to 276 hours. Let's just see what that looks like. Looks like that pattern falls apart. And we go to 384 hours, again, I'm not expecting it to be persistent. Basically an average.
That's just a regular cyclone there.
Right, that's regular cyclone.
Yeah.
Let's look at that regular cyclone.
Yeah.
Hopefully it's just liquid precip.
I think you're safe. Yeah.
All right, there we go.
Look at Minneapolis though, that's gonna be a great spring storm.
That would be a storm. I would be in the
Yeah.
model.
Yeah, in the
Anyway,
morning.
in the model, Anyway, that's it. Again, for the weekend here, looks like today, obviously through tonight, early tomorrow, pretty decent clouding up over the, tomorrow morning into the afternoon. With maybe a sprinkle or maybe even a flake of snow. And then we're gonna basically begin to, clear out and be milder actually on Sunday. So we're probably getting into one. That is it. Have a wonderful weekend. Thank you, Pete, for setting this up, and John, thank you for the discussion, and everyone, and Greg for suggestions about the chat.
Turn off the, no, well, the live stream will